Another Leetcode problem, 106, construct a binary tree from Inorder and Postorder Traversal. So let's just understand it. So we are giving two integers array Inorder and Postorder. So where Inorder is the Inorder traversal and Postorder is the Postorder traversal of the binary tree. So we're going to construct and return the binary tree. So we are giving two arrays. So one array is Inorder, another array is Postorder for the same tree. And according to the two arrays, we're gonna get a final binary tree. So for this example, it's gonna be 3 gonna be the root node, and then left side gonna be node 9, and the right side gonna be node 20. So let me just copy the array to tag which kind of a method we're gonna use to solve such kind of problem. Yeah. So for us, we need to compare the two arrays, and we just want to tag if we can find some properties of the Inorder and Postorder. So for the Inorder traversal, it's going to be the first left child, for example, it is 9, and then the root node is going to be 3, and then the right subtree is going to be 15, 20, and 7. And for the Postorder, first of all, we're going to have the left child is going to be 9, and then we're going to have the right subtree, it's going to be 15, like 20 and 7, and then we're going to go to the root. Yeah, so this is the property of the Inorder and Postorder traversal. So we're going to use such kind of properties to solve the problem. So one intuition is that why not we just start from the root node? And how can we find the root node easily? We can use the Postorder. So the last node, the last number inside the Postorder array, it must be the root node. As we can say, this is going to be a 3. So the 3 is going to be the root node. Yeah. And what's going to be the left child and what's going to be the left subtree and the right subtree? So this 3 to find where it is inside the Inorder array. So inside the Inorder array, we can find this 3 by using the index. So at the left side of this 3, it must be the left subtree. At the right side of 3, it must be the right subtree. So we're going to use this kind of property. And how can we find it easily? Because for the Postorder array, the left part and the right part is connected. Yeah. But for the Inorder, it is disconnected. So we're going to use the Inorder property. We're going to check the left side. Currently, it is only a 9. So it means the left side is going to be 1. And we don't need to take care of the right side because everything should be okay. So if the left side is 1, we're going to use this size to check it in Postorder array. Yeah. So currently in the Inorder array, we know the left subtree is going to be 9. And for the Postorder traversal, for the Postorder array, we know the size is 1. So we only take one value, it's going to be 9. So this 9 and this 9 is going to be from the left subtree. And from the right side, we just need to take the next values just after 3. So it's going to be 15, 20, and 7. This is going to be the right subtree for the Inorder array. So what about the right subtree for the Postorder array? So for the Postorder array, we just need to take the value after this 9, and we're going to take we're going to take the value after this 9, but before the root node 3. So it means those 3 values, 15, 7, and 20, is going to be the right subtree for the Postorder array. And this 15, 27 is going to be the right subtree for the Inorder array. So in this way, we can recursively call the function and get the final answer. So this is going to be a Postorder traversal to solve the problem. Actually, before we are getting the root node 3, we've already solved 9, we've already solved 20, 15, and 7 for the right subtree. And then we can directly return the root node 3. Yeah. Now let's just use this kind of idea to solve the problem. So we're going to define a DFS. Inside, it's going to be the Inorder and Postorder array. Now we're going to check the Postorder. If the Postorder is empty, and we're going to return a none. And then we're going to check. We're going to let me think about it. We're going to check the last node. We're going to check the size. We're going to check the size for this Inorder array. So I'm going to prepare a left size. So it's going to be the Inorder.index. We need to find this 3, and it's going to be the Postorder of -1. Yeah, so in this way we know that the left side is going to be 1, and we can calculate the left part. So the left part of the tree going to be the DFS. Inside it's going to be the in-order array. So it's going to be the in-order array, and the size going to be the left size. And the right part, and the post-order array going to be the similarly, it's going to be the left size because the size should be the same. And now we go to the right part. It's going to be the DFS with in order, and inside we need to use the left size plus 1 to the right side because we don't need to use this left size. Yeah, because this is in order. The left size as the index is going to be the root node. And for the post order, it's going to be the we have to be really clear with what is the meaning. So the left size is what is the size for the left part, and then we're going to use this left size as the root node for the in order array. For the post order array, it's going to be the left size 2 minus 1. And finally, we need to return the tree node. So it's going to be the post order with minus 1, the first value, and the left and the right. Yeah. So this left and right is just from the left side of the tree, and from the right side of the tree it's going to be the right. So finally, we're going to call this DFS with in order and post order. Yeah. So let me just use this example to explain it maybe. So here, first of all, we're going to find this value 3. So for this value 3, we're going to take the left side. So we're going to use the in order array.index post order minus 1 with this 3. So we find the left side is going to be 1. So for the in order array, the left part we're going to take this 9. And for the post order array, for the left part we're going to take this 9. And for the right part, so this is the right side, we're going to use for the in order array, it's going to be left size plus 1. It's going to be this part. And similarly for the post order array, it's going to be left size 2 minus 1. It means 15 to 20. So this is exactly what we are calculating. So finally, we just need to return the post order minus 1 with this node 3 and connected the left and right part. And we're going to recursively call the function until the post order array is empty. Yeah, so if it is empty, for example, for this node 9, 15, or 7, if it is empty, we just return a none. Yeah, so this is the entire code for such kind of problem. Let me just run it and submit it to Zach. Yeah, as you can see, it works and it's pretty fast. Although this is an O(n) squared time complexity, but I think this is easy to understand. So if you try to use the O(n) linear time, it's going to be much difficult to understand. Maybe you're going to forget about it. But this O(n) squared time complexity, I think it is still okay to use such kind of method because the code is much more clean than other kind of method. Thank you for watching. See you next time.